Welcome to my talk about Cinch's journey to serverless. I'm Tolly. I'm a software engineer with a background in mathematics. I like to say that I learned to write code the hard way, building software to solve large-scale optimization problems. I've since worked across a few industries, all software stacks, and many programming paradigms, both on-prem and in the cloud. In the last 3 or 4 years, I have a spiked interest in DevOps and observability practices, and especially how I can empower teams to embrace these practices so that they can excel at their goals. At my current role as Principal Practice Engineer at Cinch, I have the opportunity to put this interest into practice at an exponentially scaling organization. Cinch is a car buying platform that promises to take the faff out of finding, buying, and owning a used car. Cinch is the consumer-facing company of the wider Constellation Automotive Group. Cinch.co.uk as a website first appeared on the internet in July 2019 as a second-hand car website surfacing cars on offer from car dealers across the UK. To save you searching, the informal definition of cinch is something easy. You could say, the problem is a cinch, if the problem is easy to solve. Or you could say, adopting serverless is a cinch. Scaling Cinch exponentially, however, is not a cinch. In this talk, I'll attempt to answer the following questions. Why did we move to serverless anyway? How did this shape our organization and engineering practices? And what did we learn? I do need to provide you with some context first. We didn't start with a greenfield project. We adopted a software stack and processes built by a digital agency. Version 1.0 of our website was a dealer vehicle adverts aggregator with 100,000 plus adverts, but with relatively low traffic. Cinch as an entity only started forming in mid-2019 with headquarters in Manchester, UK. We inherited a tech stack that could be called at the time, around 2019, cutting edge. It was entirely cloud native in Azure. We were using TypeScript on the front end, C# for backend APIs and some function apps, and it was all hosted in Kubernetes clusters in Azure's managed Kubernetes offering. Our infrastructure provisioning was also infrastructure as code. You may ask, sounds like you were set up for success. What was your problem? 3 months after we took ownership of the software system, we decided as a business to scale to a direct-to-consumer model. Essentially, what this meant is that we wanted to also sell cars directly to consumers, not only via dealers. This business pivot introduced loads of uncertainty. We no longer could assume that we could achieve our goals. We were about to scale pretty radically. How radically? The pivot was decided in March 2020. We had no serverless code. We just about had 2 teams owning the existing Azure tech stack. And we knew that in October 2020, just 6 months later, we had a national marketing campaign launched to broadcast our new offering. So we're suddenly in a bit of trouble. All we knew is that to achieve our goal, we had to put ourselves in a position to iterate at pace on the one hand, but at the same time, maximize discovery. What's on all your minds now? Will what we have scale? Well, we didn't know. What we did know was that the software systems and processes we inherited did not cater for cross-functional autonomous teams that could move at pace. We also knew that we had a system built on containers and a Kubernetes cluster. We would have to build that expertise up. Given our state of play and our ambitious goals, we made 3 very important core decisions. It's important to note that we made all these decisions all at once. The first thing we did was to choose a tech stack, assume we have a greenfield project, and choose what is best for our situation. The second thing we did was to consider Conway's law, the theory that says that our software systems will ultimately mirror your organizational structure. If we want to build decoupled systems with independently deployable services, we will have to design our organization accordingly, hence making the so-called inverse Conway's law maneuver. Finally, the third decision was to establish relevant engineering principles that enhance the aforementioned tech and people decisions. To dig deeper, our first decision was to be brave and choose an entirely new tech stack. We made a series of calls all at once around our tech stack, from the target platform, including the cloud provider, to the chosen language in the back end, our source control and deployment tool, and finally, our observability and monitoring platform. We decided containers and Kubernetes clusters is not what we wanted to focus on. As evident from the title of the talk, we chose serverless instead. We picked AWS Lambda as it seemed to be the most mature serverless offering in the industry. It also has a strong community and a larger recruitment pool. We were willing to accept the cost of having a steep learning curve. Given we chose AWS Lambda, it was evident that we couldn't choose a compiled language in C#. An interpreted language seemed like the more suitable choice. We chose TypeScript due to existing expertise in the organization, hence unifying our language across all stacks. Even infrastructure ultimately is now mostly using TypeScript via the AWS CDK. Finally, Node and TypeScript also has a strong community behind it. Since we were moving away from Azure's offering, it did make sense to move our source control to GitHub. It was the most mature in the industry and had a larger talent pool, and GitHub Actions mainly due to the faster builds and simplicity. Finally, given we were switching clouds, we decided early on that moving to a dedicated observability and monitoring platform does make sense, as we knew that native cloud observability platforms would not provide the breadth and depth of functionality we would need for our ambitions, and couldn't wait for them to mature. Our second core decision was around applying organizational constraints to effectively encourage the types of outcomes we wanted. From day one, we had decided that our squads were going to be led by the pair of product and engineering. We also chose to have cross-functional teams that we call squads that could deliver autonomously at pace. We put the squad at the center of delivery. We see the squads as a unit of delivery at Cinch. A core part of our organizational design was the absence of roles or teams. Hence, we had no ops or SRE people, no QA people, and no dedicated platform people. Finally, given our tech stack and people choices, we set out to establish some core engineering principles. Serverless and AWS Lambda naturally lends itself to an event-driven architecture, so we wanted to double down on designing our software systems based on pub/sub events. This would facilitate team autonomy to build asynchronous, resilient software. Since we wanted it to move at pace and had no QA manual processes, we encouraged engineers to really think about how they can automate testing as much as possible to ensure good quality continuous software delivery. We recognized that moving in small iterative changes would minimize risk and encourage a lean approach to software delivery. We highly discouraged big bangs. Flow and feedback are inherently interlinked. We decided that from the start, we wanted to build observable systems. In this talk, I'm going to focus on two of these principles, namely flow and feedback. To achieve optimal flow and feedback, we had to establish a genuine DevOps mindset from day one. To be a true DevOps organization, we settled on the build it, ship it, support it model, where squads take ownership of the entire lifecycle of their code. As a result, we chose the DevOps topology where ops and dev were effectively overlapping entirely. Our devs were our ops. As a result of this model, squads were elite performers when it comes to software delivery performance, according to DORA research. This is important not for comparison reasons between squads or between Cinch and other organizations, but more for identifying what capabilities to work on. For example, if you score as elite, you will likely focus on Western organizational culture, which is all about psychological safety, monitoring and observability, and working in small batches, all of which were encouraged by our organizational design and engineering principles. What does our software lifecycle look like at Cinch? This is a schematic approach of what our feedback loop looks like. It will vary across squads, since squads are free to optimize their feedback loops to cater for their needs. At the center of our feedback loop is the squad. We make a strong emphasis for squads to not work as a collection of individuals, rather as a team. Pairing and mobbing is a very frequent practice at Cinch. Squads write code, write unit tests, and integrate the code often into source control. Trunk-based development is highly encouraged. PRs are used as an exception. We tend to trust our testing and count on the work having been done together rather individually in isolation. Once code is integrated, we run various quality and security checks in our GitHub Actions, and we deploy a temporary stack to run our smoke and integration tests against our deployed version of our code. Once everything is okay, we deploy a more permanent stack in dev, which serves as an integration point with other squads for end-to-end tests if needed. If everything is fine, we deploy to production. A couple of very important notes on this. A few of the more mature CI/CD squads deploy to dev and prod in parallel. As dev is not a prerequisite for them to deploy to prod, they trust their tests and automation. They work in small batches. Another important point, is notice the short distance between squads and production. This is deliberate. We wanted to minimize the path to production so that squads can focus on regression and quality on the one hand before deploying to prod, but also live closer to production. At this point, the feedback from our customers who visit our website starts. Our production systems are exercised and emit telemetry data continuously. Squads explore the telemetry data using Datadog, and they have alerts set up for anything that they expect to fail. Alerts tend to go into their respective squad channels. We do send some alerts to upstream, as we found that having a shouting tool can be very useful when we want to catch squads quickly so that we can minimize time to acknowledge as much as possible. We only do this for P1s though. As a result of this deployment pattern, a representative example from a single day at Cinch is that we perform around 80 deployments production in a single day across all squads. Commit to live in production takes on average around 11 minutes, again across all squads. Of course, this is a mean average and doesn't take into consideration distribution or outliers. Due to our software delivery approach and team autonomy and ownership, we managed to deliver one day before the national marketing campaign launch. Our first full day in prod, our production AWS account cost was less than our dev account despite the sudden very high traffic due to TV adverts. The high traffic reduced cold starts and serverless scaled beautifully. This graph displays the traffic of our first 5 days of going live. On our first 3 massive traffic spikes, the P99 latency of our APIs dropped significantly due to the drop of our cold starts. We were now in production, experiencing higher traffic than we were used to and achieving our business goals. But we were not done. We asked ourselves, were our production services delivering on their promises consistently? Was the feedback part of flow really working? This is where our story really begins, where Cinch meets its customers, Murphy's Law applied, and everything that could go wrong went wrong. Our initial few weeks live were challenging due to many manual fixes and lack of deep knowledge of how our production systems were performing. Due to the tight deadline, while onboarding more people and more squads, observability was pushed aside in favor of delivery. We quickly had the harsh realization that ops out in the wild is hard. We realized that knee-jerk reactions don't scale. They actually slow us down. Reality hit hard that we were actually finding it difficult to understand what was happening in production, and more crucially, why. And serverless alone does not guarantee reliability. We had demonstrated that we were good at building and shipping, but we were immature in supporting. It turned out the software delivery was not our challenge after all. We excelled at that part. Since we started thinking about Cinch as an idea around the start of 2019, and we were reading the Excel & Accelerate book and the DORA research, the industry has advanced. An organization that was elite in 2018 was only 7% of the total organizations. As per the latest DevOps report that was only published last month in September 2021, 26% of organizations are elite in terms of software delivery performance. What were we missing to better achieve our desired outcomes, to keep our promises? Software delivery is measured by the 4 metrics, 2 indicating speed and 2 indicating quality. But reliability, the 5th metric, measures operational performance. In 2021, operational performance was the missing piece of the puzzle. Reliability is an outcome of a series of things. Serverless provides some reliability out of the box. Good software delivery practices and good architectural design contribute as well. And core aspects like observability and monitoring and security. Since we had chosen serverless, what we could focus on is improving our observability and monitoring. We needed to know when something breaks and, more importantly, why. We also need to know how well our services are performing against the business promise we had made. If you don't mind, I will change the title of this talk to The Road to a New Architecture, Cinch's Journey to Observability via Serverless. Serverless did release some of the cognitive loads squads would otherwise have to endure. Squads now have the cognitive overhead of operating their production systems effectively. How would they do that? We were on the brink of a collective cognitive load shift from containers and platform to distributed reliability. In January 2021, having been hit hard by too much manual work to manage our production systems, we decided to leverage this cognitive load shift and take our squads on an observability journey. We defined an outline with some core milestones that the squads inevitably would achieve on their quest to mature their system's observability. What did this journey look like in practice? First milestone would be to generate useful telemetry data and instrument their code with intent. We learned when and how to use the various telemetry data types: traces, metrics, and logs for our lambdas, RUM events for the front end. Squads would instrument their lambda functions with tracing. Lambda functions are inherently event-driven. Therefore, tracing each invocation and adding more context to them with the form of span tags has provided with loads of context and visibility of the various backend journeys. From day one of moving to serverless and AWS, our Lambda functions emit custom metrics, for example, order completed or finance application started, which really help us have deep understanding of the performance of our services in terms of its business objectives. Deciding when to use these to get key insights in our business metrics from the ops perspective is key. As evident from the focus on tracing and metrics, logs are not our answer to more observability. We use logs a bit more sparingly, but they still have their place, in many cases alongside span tags and metrics, at the same more or less point of the execution path of the Lambda function. Being able to pivot between traces and logs both ways has offered that pathway for squads and engineers to utilize traces. Remember, logs are familiar, traces are scary. We have also found, though, that the free text nature of logs are familiar for non-engineers. Product owners and business analysts can make sense of these on dashboards. Finally, squads that have ownership of a front end would inevitably upgrade their front-end observability by utilizing RUM events extensively. Our front ends are automatically instrumented with extremely rich data. We don't sample our RUM data at all, but we also instrument with intent. Real user monitoring gives you end-to-end visibility into the real-time activity and experience of individual users. RUM events have definitely helped onboard front engineers on the observability train and understanding the difference between instrumentation and simply logging free text. For example, setting core custom fields like user ID, finance ID, vehicle details, etc. Being able to link RUM data to backend traces really does complete the picture, and it helps us break down the silo between front end and backend. We had to challenge engineers to understand what the various data types offer them, which introduces cognitive overhead, of course, but this would be the catalyst for a cognitive load shift to observability. In parallel with our instrumentation practice, it was evident that each squad would have to create and evolve their own dashboards. We believe that engineers who build the services know them best, so we empower them to create simple and insightful dashboards. We made an important point not to dashboard gaze though. Squads would create dashboards that give them a snapshot of their domain telemetry data to get important signals from production. They created the so-called stand-up dashboards that allow them to use the dashboard as focal points at stand-ups. Some dashboards are even used almost as an entry point for everything related to their squad with links to all squad information. With instrumentation and dashboards in a pretty good state, creating monitors off them is easy. We try to encourage a preference on white box monitoring, and we have used both our custom metrics and AWS native metrics heavily to create monitors. With a good understanding of RUM events and some good instrumentation, RUM-based monitors do upgrade our front-end monitoring capabilities to answer the question of whether we are keeping our promises. In cases that we absolutely want things on our front-end or back-end APIs to work, we have leveraged some black box monitoring by the use of synthetics. Synthetics on a schedule are encouraged to be limited to core journeys, but we do use the CI feature of synthetics extensively to tie in with our deployment patterns. What did we learn on our journey? On our instrumentation journey, we learned that using the tracing flame graphs is less useful than being able to query a dataset of spans. Adopting unified service tagging, service, env, and version really does help with having consistency across the various telemetry datasets. Especially, I'll call out service boundaries here. We found that defining a single service that encompasses all the related Lambda functions for a squad increases clarity and even helps with architectural design. Finally, we found that when we actually followed the tool's principles, Datadog in our case, our adoption and effectiveness of using the tool grew dramatically. We had a few challenges worth calling out. Engineers are used to logs. All the extra data types, metrics, traces, RUM events, do cause confusion and require substantial efforts to shift the mindset to a more holistic mental model of telemetry data. Engineers often had to see traces working to discover their value. AWS X-Ray SDK and Datadog SDKs used together are quite confusing, and most engineers don't understand the subtle differences in concepts, standards, and naming conventions. We definitely ended up overusing metrics. Although they form powerful signals, we often lost the context of the why. Finally, getting everything right at once is impossible. It really is a matter of continuous improvement. When it comes to monitors, we found out that although synthetically created traffic was what engineers are used to, we had to discourage it in favor of monitoring customer-created traffic instead. For example, there is value in having a synthetic for the homepage that runs every 1 minute, but a monitor on RUM data should do the job equally well, and we will find out more information than we would from the synthetic. You would know that the issue actually affects our customers, rather than extrapolating from the synthetic failure that it should be affecting customers too. We got a bit trigger happy with monitors, and that creates unnecessary cognitive overhead. It also creates monitor debt, if you like. Principles from testing, for example, delete tests if they don't provide value anymore, or technical debt, do apply to monitors too. So be conscientious when creating monitors. We did have some challenges to get our monitor to serve our purpose. The up to 10-minute lag between AWS and Datadog did create a bit of uncertainty and lack of accuracy for us. There are ways around it now, but it's something worth considering when implementing monitors on telemetry data that may incur a serious lag to be ingested. AWS X-ray sampling did prevent us from using monitors on trace data. It also limited the adoption of traces too. Finally, as a continuation of our tip around creating too many monitors, alert fatigue is real and should be addressed like you should with a frequently failing pipeline or flaky tests. Technical change to achieve higher observability does not take place without creating or evolving squads practices. Many common practices naturally emerged once the squads were given the task to mature their support of their slice of the production systems. One thing I would call out here is the practice of regularly reviewing dashboards daily during stand-ups or even stand-downs at the end of the day, and weekly to identify improvements. Of course, the squads did not go on the observability journey without explicit organizational design to support them. Squads had no ops, manual QA, platform, or SRE teams that they could rely on. What they did have was a dedicated software engineer, the so-called automation engineer that was embedded in each squad to take ownership of the entire lifecycle of the code and enable the squad to grow their capabilities together though. Rather than forming a separate team, this role was embedded in each squad. The core aim of this role would be that the squads can independently deploy at pace and with quality, and they could also evolve their observability capabilities to increase their confidence in their system's reliability, and more crucially, know when their service is honoring their promises. This role is not there to do all the work with the squad. Rather, the goal is to bring the rest of the squad on the observability journey with them. Initially, when we first moved to serverless, we were short on these roles in the squads, and many squads were missing one, with their observability suffering as a result. We also supported these roles by initiating and facilitating a community of practice around DevOps and observability. Lately, we have recruited some principal engineer roles that support the squad's efforts. Our next steps in operational performance are: create good SLOs that may replace some monitors, adopt patterns like using Lambda extensions to send out telemetry data to Datadog directly. We have found the hard way how tedious incident management can be, so we will be looking into tooling and more chaos days to improve. We'll be looking to expand on our capabilities by including CI/CD observability. Quality, deployment frequency, and lead time should be at the forefront of all our squads. We'll probably find ourselves applying the same collective cognitive load shift to security quite soon. Eventually, we did reach a level of observability that increased our confidence and has started to pay back for the extra cognitive overhead the squads had to endure. A year after our initial launch, we continue to deliver at pace with true observability at the core of our engineering practices. Major incidents are a very small percentage of our deployments to prod. Percentage of failed deployments has actually gone down as the number of our deployments increased. What did this mean for Cinch? Serverless enabled us to focus on production, despite our initial challenges, ultimately focusing on delivering value to customers. We distributed the responsibility to the squads. They are leading the way. We achieved fast flow with short and immediate feedback loops. We became truly experimentation-led. Given our wins, we do have some current and near future challenges. Moving to AWS and serverless did require a rather steep learning curve, which we were attempting to address with communities of practice, certifications, and learning platforms. We have found that we need other types of teams other than our squads to further decrease the cognitive overhead of the squads as we scale. Infrastructure to manage our growing AWS accounts estate. We managed without a dedicated team for a while. Platform to have our squads as customers and enable them to focus on their work. An example here is that inventory of vehicles or the design system is a platform on which other teams can build on. And finally, enabling. Short-lived, highly technical consultative teams that perform some work to solve cross-cutting problems. Distributed systems built by autonomous squads working entirely remotely present a real challenge for achieving the right type of communication and collaboration. We aim to focus on scaling via emphasizing async forms of collaboration more. We have found that communication between squads is not optimal. We're looking into ways and ideas to optimize this communication. Since we have spent the past 1.5 years scaling the organization entirely remotely, we do wonder what the near future will look like when we have the option to meet in person for day-long workshops, for example. But you may wonder, what did this journey mean to me? I started at Cinch being asked to become a Kubernetes expert. Instead, I learned a lot about serverless deployment patterns and how you can build truly observable systems. I also learned that it requires both tech and people skills. Rather than talking about infrastructure concepts, in our case Kubernetes, I find myself talking about domains and important metrics for those domains that directly relate to our customers. If I had to summarize the driving forces behind our journey to true DevOps and high observability in the serverless world, that would be: choose your tech stack wisely. If Kubernetes offers the collective cognitive load shift towards observability, that's cool. For us, it was serverless. Choose engineering principles to achieve continuous flow and feedback. Finally, give ownership to your teams. Trust them and let them fly. As a final note, be patient with DevOps and observability though. Continuously delivering and supporting and operating production systems do not come easy to software engineers. Support them, particularly when you are growing entirely remotely. Thank you. Please do get in touch if you have any questions or feedback. We have plenty of jobs on offer if you check our website. Look forward to seeing you in the QA.